Welcome dear students. Today we are going to discuss a very conceptual problem in variable mass system. I want you to attempt it first, so you may pause the video and try it yourself. Then you may look at my solution. It will definitely give you a better insight in the dealing of variable mass system. So the question says that there ends of a thin uniform inextensible rope of mass m and length l are fastened to the ceiling close to each other as shown in the figure. If one of the ends is released and allowed to fall freely, find the largest tension in the rope at the other end fastened to the ceiling. So let us say this is the uniform rope and this is the end A of the rope and this is the end B of the rope. At certain point of time, this end is released and it is allowed to fall down freely under gravity. So, and what is the mass of this rope is m and its total length is L. So, we have to find the maximum tension at this point A, which is fastened to the ceiling. This is the ceiling. So, how we are going to deal with it? Let us see. Suppose this is the situation. Okay, this is end A and end B is released. So, after some time, what will be the situation? Situation will be something like this. B will have reached here, A is still fastened, and what do you think? Why will the tension be here on this string? What is the cause of tension and why will it vary with time? Let us see. First visualize this part, because physics and mathematics definitely go together, but visualization is an entirely different thing. So let us visualize. Tension will be due to two parts. First, weight of this part. Let us say at some instant of time, at this instant, the weight of this, let us call it branch 1 and this one as branch 2. Okay. If weight of mass of branch 1 is m at this time, so tension is what? mg. One component of tension is due to weight of this hanging part, plus what do you think? Let us see what is happening at this small end. At some point of time, when let us say it is a very small length dx. Okay, this is a very small length dx, and what is its velocity? Suppose this end is falling down with velocity v. That means this dx is also falling down with velocity v till it is a part of branch 2. Okay, so dx is falling down with velocity v. This dx will have some mass of what? dm. Dm will be what? Lambda dx, where lambda is what? Lambda is the mass density of the rope, that is m upon L. Okay, so you see, within a short span of time, let us say within a short span of time dt, this dm mass comes down and becomes a part of this branch 1. In a short span of time, this rope becomes something like this. So earlier the dm which was in branch 2, now it has come as a part of branch 1. And what will be its velocity when it has come here? Its velocity will be 0, because this branch is fully fastened here with the ceiling. So here its velocity will be 0. So you see what is happening. When it is here, its velocity is v, and within a short span of time dt, its velocity has become 0. That means there is some change in momentum. Let us say this is dm. It was moving with velocity v, and in a short span of time dt, it has become 0. Its velocity has become 0. All this happened in a span of time dt. That means what is the force scenario on this? Some force has definitely acted upwards on this dm to stop it from falling down continuously. What is that force? Force we know is what? Rate of change of momentum. And what is the change of momentum over here? It is nothing but dm times v, dm times final velocity minus initial velocity, that means v minus 0 or v upon dt. This much force has been applied on this small element dm to stop it from falling down with this velocity v. Who has applied this force? Definitely this string has applied this force F. So this force, this component will also be added to the tension at the upper end. That means tension at the upper end is because of the hanging mass plus the impulse of the falling string at the lower end. So tension is what? Tension is mg plus dm v dm by dt at the lower end. Okay, this is the tension at A, and this is what we need to calculate. I mean the maximum value of this tension we need to calculate. So what do you think, when will this tension be maximum? Now you see, what is the final scenario? Final scenario is something like this. A is here and point B has reached to the lowermost end, and this whole string length is now open. It is length L. So at this time, what is the value of m? M will be maxima because whole string is now open. So m will be maximum, and what will be the value of v? Definitely the point v, this was falling freely from here to here. I mean from this point to this point, velocity of b will be increasing only. So velocity will become maximum when b reaches the lowermost point. So v is also maximum in this scenario, and dm by dt, this also depends on the velocity of b. So this will also be maximum when string is fully open. That means we can say that the tension at A will be maximum when the string is fully open, isn't it? So what we have to now find, we have to find the tension at A when string has been fully opened like this. In this situation we have to find it. So let us analyze the problem, how it is happening. This is the situation. At some instant of time, let us say this string, I mean its length is x. This is point A and the open length is x. Okay, at some instant of time, let us, this is the scenario. So whole I mean rope length is L. So what will be this length? B, this point is B. This will be what? Simply by adding the length of the string, you can say this will be 2x minus L. Okay. Now what you can say about, let us say that the velocity of the B here is what? V. The polar velocity of this end is V downward. So if velocity of B is V downward, what can you say about the velocity of this lowermost point? It will be V by 2 by the constraint of the string, because length of the string is remaining constant. So this is V by 2. Now let us see what is happening within a very short interval of time dt. Within a short interval of time dt, B will move by how much? B will move by V dt. No doubt in this. So what will this end move down? Let us draw here. It will move down by some small element. What? This will be what? V by 2 dt, isn't it? That means how much mass is added to this branch. This is the first branch and this is the second branch. I mean how much mass has added in this branch? Simply lambda times the length which has added. Length what is added is this much, lambda times V by 2 dt is the dm mass which has gone from 2 to 1. This mass has grown from branch 2 to branch 1. Okay. Now you see what is the change in momentum of this dm. When this, suppose this is the situation, when this dm was here, it was traveling down with velocity v, and the same dm when it reached back at this time, I mean let us say here, the same dm when it reached traveling like this, it reached here, then what is velocity? Its velocity is 0. So what is the change in momentum of this dm? Initial momentum was what? V times dm. This was initial momentum. Final momentum was what? 0. This was final momentum. What is the time elapsed? Dt. So change in momentum what? Delta p is what? Change in momentum upon dt, if we say, is v dm upon dt. V dm upon dt. dm is what? You see here we have mentioned dm is lambda by 2 v dt. So you can write it what? V times dm upon dt is lambda v by 2. Lambda v by 2. So this is what? This is lambda v square by 2. So this is dp by dt. That means this is the force F which we were discussing at this point A. A we discussed what? A tension is what? Hanging part weight mg plus this dp by dt or force F. We have already discussed in the previous slide. So tension is what? Mg plus F. That means we can write tension is what? Mg plus F is what? F is lambda v square by 2. Mg plus lambda v square by 2. Okay. Now this you need to simply put the value when whole string is open in this expression and you get the answer. So what is happening when the whole string is open? Let us see. We have got T is equal to what? Mg plus lambda v square by 2, and when the whole string is open, I mean this is the situation, whole string has open and its length is L, then what is the total mass of the hand in this string? Total mass is m only. What is the velocity of this point? B has now reached the lowermost point. What is the velocity of this point here? Initially B was where? B was at the ceiling, and finally B has reached at this point. So how much distance the B has fallen? B has fallen down distance L, and the fall of B is a free fall. At any point of time, if you see B is somewhere here, then B is falling under gravity only, because tension in this part is 0. So you can easily calculate the velocity of B by what? Half, let us say small mass of BB dm, half dm v square is equal to potential energy when it was at the ceiling, dm times g times L. Now dm cancel. So v square is what? V square is 2gl. Okay. Put this value of v in this equation. So what you get? You get T is what? Mg plus lambda is what? Mass of string upon length times v square by 2 is what? Gl. L and L cancel. So T is what? T is simply 2 mg, and this is the answer. This is the maximum tension on the other end A when the whole rope gets opened. So I hope it is very clear, and in case you have any queries, any doubts, any questions still there, please feel free to mention it in the comments. I will try to reply your comments immediately. Thank you.